Welcome to this video about Q equals mc delta T. This is the equation we use to calculate the amount of heat in calories or joules that is going on in a reaction. Just real quick, a reminder, Q represents the heat, and that can be in calories or joules, which is, again, you guys remember the metric unit for heat. Okay, then we also have the mass, which is M. That is in grams. And then we have C, which is specific heat capacity. And remember, that one's in calories over grams times degrees Celsius. And again, that is the amount of heat that it takes to raise 1 gram of a substance up 1 degree Celsius. For water, that value is 1 calorie per gram degree Celsius, and a lot of the problems we do in our class involve water, so it's pretty common. That value is given to you on a test. You don't have to remember it unless you're calculating for C by itself. Okay, last thing is delta T. Delta T is a change in temperature, and the units for that are degrees Celsius. So just a reminder of what everything stands for as far as the variables. And next we'll run a couple of practice problems. Okay, so we have a question here that says, how many calories of heat are required to raise the temperature of 50 grams of water up 20 degrees Celsius? The first thing I do when I'm doing these problems is I figure out what each variable is represented by. So for instance, it says how many calories here. That's going to be the Q. Anytime I see calories of heat or joules of heat, that is the Q. I see this 50 grams, that's the mass. I see up 20 degrees Celsius, that's a change in temperature, which is delta T. The C for water, which should be given to you, is 1 calorie per gram degree Celsius. So this one, we basically set up the equation like this. Q equals M times C times delta T. We plug in the M, go back to our problem here, and we have the 50 grams, which is shown there. We're going to multiply that by the C, which is the 1 calorie per gram degree Celsius. And then we're going to multiply that by the change in temperature, which is 20 degrees Celsius. So you run that through a calculator, and it's just 50 times 1, which you don't have to put in there, times 20, and you're going to get 1,000. Now, as far as the units for that, if you look at what we have here, remember when you're canceling units, you want to cancel 2 of everything. So if you have 2 grams, cancel those out because they are on the top and bottom of a fraction. You have 2 Celsius, you want to cancel those out. You notice what we're left with is calories, and that's what the answer should be in because that's what it's asking for up here. So that's a real simple one with just Q equals mc delta T and not having to do any algebra moves on this one. Okay, for this next one, the question says, what is the specific heat capacity of a substance that requires 400 calories to raise the temperature of 10 grams up 40 degrees Celsius? So again, my attack here is to go in, figure out what I have. So it's asking for the specific heat capacity, which is C. So that we need to get. Okay, 400 calories. Again, if you see calories, that's Q. You see 10 grams here, that's M. And I see up 40 degrees, which is delta T. Okay, so we start off with our original equation. Q equals mc delta T. And now we're solving for C. So remember in algebra, if you have these guys that are multiplying with each other, to get rid of them you need to do the opposite. So if we need to get rid of the M and the delta T, we divide. So if we do it on this side, we have to make it equitable, make it equal. by doing it on this side. So you're going to notice that when you're doing these equations, and I mentioned this in class, no matter what you do algebra-wise, Q is always going to be on the top of that equation when you're done. So everything else goes on the bottom, and I call that the leftovers. So Q's on the top, leftovers on the bottom. What you want is now by itself. So let's go back over here. We'll plug in the numbers that we found. Remember Q, go back up here. Q is 400. That's calories. The bottom we have M, which is the 10 grams. And then that's going to be times the change in temperature, which is 40 degrees Celsius. In the calculator, you want to make sure to put in 400. There's a couple of ways you can do this. I think this one is the easiest, but you can do it however you know how to do it. 400, hit divide, put in 10, hit divide again, put in 40, and you're going to end up in this case with 1, which, if you remember, is the same as water's specific heat capacity. So we could actually figure out that this substance is probably water because we found its specific heat capacity. So our answer would be 1 calorie per gram degree Celsius. It's not always going to be 1. In this case, it happens to be the same as water. Okay, this one is a tougher problem. You still start out with Q equals mc delta T, but we're going to use a slightly different version of the equation. So before we do that, let's go through and see what we have. We have 30 grams, which you guys know is the mass. Now it says it's at 15. Now when you see at, that does not mean there's a change. That's what we're starting at. And so we call that starting temperature in chemistry the initial temperature, or TI. So that's going to be TI. Then we see the 1,000 calories of heat, which you guys know is Q. This is water, so we know the C equals 1 calorie per gram degree Celsius. Again, that's always given to you. You don't have to memorize it. And we're going to look at a couple of versions of Q equals mc delta T that can help you here. So we have Q equals mc delta T, but there is another way to write this so that you can do these problems. So let's look at adjusting this. So we can actually take the delta T and replace it with TF minus TI. And the F stands for final and the I stands for initial. So to get the delta T, we always subtract the final temperature minus the initial temperature. So this can just as easily be written as this. And you'll notice we're being asked for the final temperature, which is TF. So the problems work the same way. To get rid of M and C, we divide, and that gets those guys over here. So then we end up with Q over MC equals TF minus TI. And so remember that if you want to get rid of the TI and get it over to the other side and get TF by itself, you have to do the opposite of what's happening with them. So if this is in a minus situation, we have to add TI. And so we're going to add it to the Q over MC. So we get Q over MC plus TI equals TF. Then we go ahead and plug in our numbers into the equation. So we go ahead and plug in, and so we're going to have the Q, which is on the top, over M, which is 30 grams, and that's going to be times the C, which is 1 calorie over grams degrees Celsius, and then plus 15 degrees Celsius. So this is the TI that we had earlier, the Q, the M, and the C. Once you run all the numbers in the calculator, you should end up with an answer of about 48.3 degrees Celsius. So What we're basically saying is if we add 1,000 calories of heat to 30 grams of water, we can take it from an initial temperature of 15 Celsius, you have a thermometer in it, you add that amount of heat to that much water, and it's going to go up to 48.3 degrees Celsius. And that's really the toughest problem you have to deal with on the test as far as Q equals MC delta T. So I hope this was helpful. If you have more questions, come in and see me. Message me on Facebook, or I'm sorry, on YouTube, or you can message me on Remind. And the best thing you can do is come in and see me, and we'll go over it if you have more questions.